So here are three leaves, and I want to explain the differences between them. The one on your left is this one, and it has a very thin characteristic. It's very pale, it's showing quite a lot of nutrient deficiency, it's not hairy underneath, it doesn't have the sort of thickness, it's very light. But it's the same age as the other two leaves. These are from two different trees, Warner's King and Monarch. And both of these trees show a similarity. They've got thick, waxy leaves, they've got strong growth, they've also got hairs on the back, which are called trichomes. And you can see, although they're slightly different colours, different shapes, they're round and they've got that leathery feel. And what's so important about this is that this is really at the very heart of the regenerative growing process. The reason for these differences and the effect that that has on the trees is very important. This tree is not getting much nutrition through bacteria and fungi. It's getting a lot of it directly. The major traditional route in people's understanding of nutrition is that it comes in through the roots, dissolved in water, pretty much like in a hydroponic system. And the water carries the nutrients in, the tree takes them up and it metabolizes them. And that puts the tree at quite a disadvantage. And the reason is because that takes a lot of energy away from the tree, and the form of nutrition, the nitrates, the phosphate, ions, are difficult to manage, and they need to be metabolized by the roots and turned ultimately into protein, all of which puts the tree under a lot of stress. When the nutrition in these trees arrives, it's already part assembled. Big molecules, big protein-based molecules, full of the necessary nutrients, but the significant difference is it's come from the bacteria and fungi in the soil. And that gives the tree a much higher level of health, and it gives it an inbuilt resistance to fungi, bacteria, and very importantly, chewing and sucking pests. And it's the reason that regenerative growing is so important, because you don't need to spray for pests, you don't need to feed in the same way, your input costs are much lower, and importantly, your water costs are very low because the plant needs far less water as a result of all of this nutrition. And that's what we're going to be looking at in the next few videos. So let's look at the different reactions that chewing and sucking insects have to the two types of leaves. Let's look at the first leaf. This is one which is nutritionally deprived. It's really only got nitrates and possibly ammonium ions in there, which come in through fertilizers. And you can see it's very thin, it's very weak and floppy, and sap-sucking insects will really enjoy this sort of leaf, and as will caterpillars like winter moth. If you look at the second group of leaves, these have got a much waxier coating, they're armoured by lipids, and they also contain secondary plant metabolites, which are anti-feedants. So physically they're defending against insect attack, but also chemically they're able to defend themselves. And that's so important that you get your nutrition through the microbiome. You'll only do that if you're feeding with a regenerative system. Just talk about the fungal and bacterial effects of regenerative growing. This is the weak leaf, it's thin, and if a fungal spore or a bacterial spore lands on this leaf has very little defense. Physically, it has a very thin level of membrane, epidermis, so it's easily infected and the spore can germinate and grow in there or come in through the stomata in the base. These leaves, of course, are physically protected. They've got that waxy coating, so the spores landing are going to find that very difficult to penetrate. But secondly, there are plant metabolites like terpenes and quercetines, which are extremely good at metabolizing and damaging the invading fungi and bacteria. And usually, all of these diseases are conquered by the actual chemicals inside the leaf, and that's so important. So if you want to have healthy leaves that are disease suppressive and anti-feedant for the bacteria and the fungi spores, and of course the insect life, what do you need to do? Well, you need to encourage the microbiome to be extremely efficient and use a regenerative system that we have here. We feed with our basalt rock dust, which feeds the microbiome very efficiently, supplying the trace elements like molybdenum and boron, calcium and zinc, which promotes the enzyme activity in the leaves. But also, we keep the ground covered, we never uncover the ground, and most importantly, never feed with salt fertilizers like nitrates and ammonium fertilizers and phosphates and chlorides, because you'll wipe out your microbiome and you'll never achieve this level of plant health.